May 1, 1983, Negev Desert, Israel. Two F-15 Eagles versus A-4 Skyhawks. Routine training exercise, 11,000 feet altitude. Then, metal meets metal at supersonic speed. The Skyhawk explodes, its pilot ejects, but the F-15 doesn't fall. The entire right wing is gone, sheared off at the fuselage. Yet somehow, impossibly, the aircraft remains airborne. This is the story of Captain Zivi Nedivi and the day he landed a fighter jet with one wing. The mission was simple: airfield defense exercise. F-15 Eagles defending against attacking A-4 Skyhawks. Clear sky, perfect conditions, experienced pilots. Captain Zivi Nedivi flew F-15D serial number 957. Behind him sat instructor Yehoar Gal. This wasn't basic training. This was advanced combat maneuvering for qualified pilots. The F-15 Baz, Hebrew for Falcon, represented the peak of Israeli air power. Twin engines producing 48,000 pounds of thrust, maximum speed, Mach 2.5. But its most important feature would turn out to be something nobody expected: the wide, flat fuselage between the engines. The exercise began normally: radio chatter, visual confirmations, aircraft positioning for attack runs, then contact. Nedivi turned into his attack profile. An A-4 maneuvered simultaneously, closure rate, hundreds of miles per hour. Neither pilot had time to react. The A-4's fuselage struck exactly where the F-15's right wing joined the fuselage, the wing root. The smaller Skyhawk came apart instantly. Its pilot ejected successfully into the desert below. Nedivi's F-15 entered an immediate violent spin. "I felt a huge strike," Nedivi later said. "At first, I thought we'd just passed through jet wash. Then I saw the massive fireball from the Skyhawk explosion." In the rear seat, instructor Gal shouted, "Eject, eject!" But Nedivi made a split-second calculation. The engines were still running, both functioning perfectly. If he could add power, maybe he could recover. He slammed both throttles into afterburner. The twin engines responded. Nearly 50,000 pounds of thrust pushing the crippled aircraft. The spin slowed, stopped. The F-15 steadied. It was flying again. Neither pilot yet understood what had happened. They looked right, trying to assess damage. All they saw was dense fuel vapor pouring from the wing area, so thick they couldn't see past it. They assumed the wing was damaged but present. They had no idea the entire wing was gone. Nedivi attempted to slow down, thinking slower flight would be safer for a damaged aircraft. The moment he pulled back the throttles, the F-15 immediately entered another spin. Lesson learned instantly: speed was life. Whatever damage they had, the aircraft needed velocity to stay airborne. Nedivi pushed throttles forward again. The aircraft stabilized. He pointed the nose toward Ramon Air Base, 10 miles away, the nearest suitable runway. Fuel gauges showed critically low levels. They had minutes at most before flameout. Neither man knew they were attempting something aviation engineers would later call aerodynamically impossible: flying a fighter jet with one wing. Nedivi's wingman had watched everything: the collision, the explosion, the spin recovery. And then he saw something that made his blood freeze. The entire right wing was gone, not damaged, gone. Only a 2-foot jagged stump remained protruding from the fuselage. He keyed his radio immediately. "Zivi, you have no right wing." Inside the cockpit, Nedivi processed these words. No right wing, impossible. The aircraft was flying. He glanced right again through the fuel vapor, still couldn't see clearly. "Say again?" "You have no right wing. The entire wing is gone." Nedivi's mind raced. Every principle of aerodynamics he'd learned said this was impossible. Aircraft need wings to generate lift. Remove one wing and the aircraft becomes catastrophically asymmetric. Immediate unrecoverable roll, ground impact. Except the F-15 wasn't following these rules. What Nedivi didn't know: the F-15's unique design was accidentally saving his life. McDonnell Douglas engineers had created something unusual when they designed the Eagle in the 1970s. The wide, flat fuselage between the engines generated about 40% of the F-15's total lift. This wasn't intentional, just a side effect of packaging two massive engines side by side with space for weapons and fuel between them. At 500 miles per hour, this fuselage acted like a giant lifting body. Additionally, the massive horizontal stabilators at the rear, each nearly as large as a smaller fighter's entire wing, were creating downforce that counterbalanced the lift from the remaining left wing, like using a giant lever to balance the aircraft and the engines. With afterburners engaged, the F-15 produced nearly 48,000 pounds of thrust, more than 1-to-1 thrust-to-weight ratio. The engines alone could theoretically accelerate the aircraft vertically upward. This excess thrust effectively powered through the aerodynamic instability, using brute force to keep the aircraft moving fast enough to generate sufficient fuselage lift. But this delicate balance required one critical element: speed. Enormous speed. Nedivi checked his fuel gauges again. Fuel was hemorrhaging from the severed wing. The F-15 carried fuel in cells distributed throughout the fuselage and wings. When the right wing sheared off, it had opened multiple fuel tanks to the atmosphere. Jet fuel poured out at hundreds of gallons per minute, vaporizing instantly in the 500-mile-per-hour slipstream. The fuel vapor cloud streaming behind created its own danger. If it ignited, from engine exhaust, from static discharge, from any spark, the F-15 would become a fireball. But fuel was also their only hope. Without fuel, the engines would flame out. Without engines providing thrust, the fuselage couldn't generate sufficient lift. They would fall. Ramon Air Base, 10 miles away. Current speed, approximately 460 knots. 530 miles per hour. Fuel remaining, unknown, but dropping fast. Time to runway, roughly 1 minute, maybe 90 seconds. They might make it. Might. In the rear cockpit, Instructor Gal repeated his assessment. "Zivi, we need to eject. This aircraft cannot be landed. The manual says..." "There is no manual for this," Nedivi cut him off. His voice remained calm, focused. "We're flying. The engines are good. We have fuel. We're going to land it." This was the gamble. Ejection from an F-15 at high speed and low altitude carried risks. Spinal compression injuries, parachute failure, landing in hostile terrain. But ejection was survivable. Known, tested, documented, landing without a wing. No one had ever attempted it. No one had ever survived to attempt it. Gal's training said eject. His experience said eject. Every procedure written for emergency situations said eject. But Nedivi outranked him, and the aircraft was still flying. "Your decision," Gal finally said. He would support whatever choice Nedivi made. Ramon Air Base appeared ahead. The Israeli Air Force controller received the emergency transmission. F-15 inbound, major structural damage, preparing for immediate landing. Fire trucks scrambled, ambulances positioned at the runway threshold. Every available emergency vehicle moved into position. Ground crews who saw the approaching F-15 through binoculars couldn't believe what they were seeing. The aircraft looked grotesquely asymmetric, one wing normal, the other side just fuselage. It resembled a bird with one wing torn off, yet somehow remaining airborne. Nedivi established the aircraft on final approach. Normally, F-15 pilots landed at approximately 130 to 140 knots, around 150 to 160 miles per hour, but Nedivi's crippled Eagle couldn't survive at that speed. If he slowed down, the fuselage would stop generating sufficient lift and the aircraft would roll inverted. He had to land fast, very fast. He kept speed at 260 knots, 300 miles per hour. This was twice the normal landing speed. The runway at Ramon was long, 8,000 feet, but it wouldn't feel long at 300 miles per hour. Every minor adjustment to the flight controls produced exaggerated reactions. Touch the stick slightly left, the aircraft rolled aggressively. Slight right input, sluggish response fighting against the missing wing. The horizontal stabilators worked overtime, constantly adjusting to maintain lateral stability. Nedivi's hands moved in tiny, precise increments. Millimeters on the stick, degrees of pressure on the rudder pedals. He was flying on instinct now, feeling the aircraft's behavior, predicting its reactions before they happened. Altitude, 1,000 feet, 500 feet. The runway appeared ahead, a long strip of concrete in the desert. Fire trucks lined both sides, red lights flashing, 300 feet. Nedivi's breathing remained controlled, his hands steady. Behind him, Gal gripped his ejection handles, not pulling, but ready. If the aircraft became uncontrollable in the last seconds, they would have perhaps 1/10 of a second to eject before impact. 200 feet. The F-15's landing gear was already down. Nedivi had lowered it earlier despite the increased drag, needing whatever stability the extended gear provided. 100 feet. The scarred desert floor rushed up to meet them, 50 feet. Nedivi began his flare, pulling the nose up slightly to reduce vertical descent rate. The aircraft fought him. The missing wing created unpredictable aerodynamic effects and ground effect. The air compressed between the fuselage and runway below. 10 feet, he held the stick firm, maintaining just enough nose-up attitude to soften the landing without stalling, and then contact. The main landing gear slammed onto concrete at 260 knots with violent force. The entire airframe shuddered. Nedivi immediately deployed the drag chute, the large parachute that deploys from the tail to help slow the aircraft. The drag chute streamed out, inflated, and then instantly tore apart under the excessive speed. The fabric couldn't handle 260 knots. It disintegrated. No drag chute, full speed, 8,000 feet of runway ahead but disappearing fast. Nedivi stood on the brakes. The F-15's anti-skid system prevented the wheels from locking, but barely. Smoke poured from the tires. The brake temperatures climbed toward failure limits. 7,000 feet remaining, 6,000 feet. The aircraft was slowing, but not fast enough. 5,000 feet, 4,000 feet. Nedivi could see the end of the runway approaching. Beyond it, desert terrain, rocks, and a shallow arresting barrier designed to stop aircraft in emergencies, but at much slower speeds. 3,000 feet remaining. The brakes were screaming now, literally screaming as superheated metal ground against metal. 2,000 feet. The speed dropped below 100 knots. The aircraft became controllable again. 1,000 feet. Speed, 50 knots. The end of the runway was right there. 500 feet remaining. The F-15 rolled to a complete stop 20 feet from the end of the runway. Silence. Then, from every emergency vehicle, from every ground crew member, from the control tower, cheers erupted across the radio frequency. They had just witnessed something that shouldn't exist. A fighter jet landing without a wing. Nedivi sat in the cockpit, hands still on the controls, breathing deeply. Behind him, Gal unstrapped and slapped him on the shoulder. "That," Gal said, "was the best flying I've ever seen." Nedivi and Gal climbed down from the cockpit. Their legs were shaking, not from fear, but from the adrenaline dump that follows extreme stress. Ground crews surrounded the F-15, staring in stunned silence at the right side of the aircraft, where there should have been a wing spanning nearly 14 feet from fuselage to wingtip. There was nothing. Just a jagged stump approximately 2 feet long with torn metal, severed hydraulic lines, and fuel still dripping onto the concrete. The shear point was clean, surgical almost. The A-4's fuselage had struck at the wing root with such force and precision that it had severed the entire wing assembly in one impact. No bending, no partial damage, complete amputation. One maintenance chief walked slowly around the aircraft 3 times without saying a word. Finally, he looked at Nedivi. "This is not possible. This aircraft should not fly." But the evidence was undeniable. Rubber still smoked from the brake assemblies. The left wing was intact. The fuselage showed scorch marks from engine exhaust running at maximum afterburner for an extended period. The landing gear struts were compressed from the violent touchdown. Every sign confirmed what everyone had just witnessed. This aircraft had flown and landed without its right wing. Within hours, Israeli Air Force Command contacted McDonnell Douglas in St. Louis, Missouri, the manufacturer of the F-15 Eagle. The conversation went exactly as you'd expect when telling aircraft engineers their plane had done something impossible. Israeli officer: "We have an F-15 that landed after losing its entire right wing in a mid-air collision." McDonnell Douglas engineer: "You mean damaged wing? How much of the wing?" Israeli officer: "No, the entire wing, severed at the root, gone." Long pause. McDonnell Douglas engineer: "That's not possible. The aircraft would be uncontrollable. The pilot would need to eject immediately." Israeli officer: "The pilot did not eject. He flew 10 miles and landed at 260 knots. Another pause. McDonnell Douglas engineer: "We need to see this aircraft." A team of McDonnell Douglas engineers flew to Israel within days. They brought technical manuals, design specifications, aerodynamic models, everything they'd used to create the F-15 in the 1970s. They needed to understand how their aircraft had violated its own design limitations. The lead engineer approached F-15D serial number 957 with a notepad and camera. He documented everything: the shear point, the remaining wing stub length, the control surface positions, the fuel system damage. He measured angles, calculated weights, estimated the center of gravity shift when the wing departed the aircraft. Then he ran the numbers through aerodynamic formulas. The calculations showed exactly what intuition suggested. The aircraft should have entered an immediate unrecoverable roll to the right, followed by inverted flight and ground impact within seconds. Except it had. The engineers eventually identified 3 design features that had accidentally combined to create the impossible survival scenario. First, the lifting body fuselage. The F-15's unusually wide, flat fuselage generated approximately 40% of the aircraft's total lift in normal flight. This wasn't intentional. It was a side effect of packaging 2 massive engines side by side with enough space between them for weapons bays and fuel tanks. The resulting shape happened to be aerodynamically efficient at generating lift. When the right wing disappeared, this fuselage lift became critical. At 500+ miles per hour, the airflow over the wide fuselage created enough lift to partially compensate for the missing wing. Second, the massive horizontal stabilators. The F-15's horizontal tail surfaces aren't traditional stabilizers. They're all moving stabilators that can deflect through large angles to control pitch. Each stabilator is enormous, nearly the size of a complete wing on smaller aircraft. When the right wing sheared off, the remaining left wing created asymmetric lift trying to roll the aircraft right. The stabilators, working at maximum deflection, created a downward force on the left side of the tail that counteracted this rolling moment. It was like using a giant lever to balance the aircraft. Third, the massive thrust-to-weight ratio. With afterburners engaged, the F-15 produces nearly 48,000 pounds of thrust, while weighing approximately 45,000 pounds fully loaded. That's more than 1-to-1 thrust-to-weight ratio. The engines alone could theoretically accelerate the aircraft vertically upward. After the collision and fuel loss, the aircraft was much lighter, probably around 35,000 pounds. The engines were producing 48,000 pounds of thrust. This excess thrust effectively powered through the aerodynamic instability, using brute force to keep the aircraft moving fast enough to generate sufficient fuselage lift. McDonnell Douglas engineers returned to the United States and programmed the scenario into their flight simulators. They input the exact conditions: F-15D at 11,000 feet, right wing severed at the root, engines at military power, speed 500+ knots. They ran the simulation 20 times with different inputs and pilot responses. Result: crash every single time. The simulator could not replicate what Nedivi had done. Even knowing the outcome was possible, even with experienced test pilots attempting the scenario repeatedly, the simulator predicted unrecoverable flight in every iteration. The engineers eventually concluded that the simulation models didn't account for one critical variable: pilot instinct and micro-corrections. Nedivi had made hundreds of tiny control inputs during those 10 miles of flight, adjustments so small and rapid that they couldn't be programmed into a simulator. He had flown by feel, by intuition, developed through thousands of hours in fighters. The simulator didn't have intuition. The simulator crashed every time. McDonnell Douglas faced an interesting public relations dilemma. On one hand, they'd built an aircraft so tough and aerodynamically sophisticated that it could survive catastrophic damage. Excellent marketing. On the other hand, they couldn't officially claim the F-15 could fly on one wing because that would encourage pilots to attempt landing instead of ejecting, which would likely result in deaths. The official statement was carefully worded. The F-15's unique design characteristics, including its high thrust-to-weight ratio and lifting body fuselage, provided controllability in an extreme asymmetric flight condition. However, this incident remains exceptional and should not be considered representative of normal emergency procedures. Translation: yes, it happened. No, don't try this at home. Zivi Nedivi expected a medal, or at least a commendation. He'd saved an aircraft worth $30 million. He'd demonstrated extraordinary piloting skill under impossible conditions. He'd proven the F-15's capabilities beyond anyone's imagination. Instead, he was grounded for 3 months. The Israeli Air Force Command's reasoning was brutally practical. Nedivi had violated standing orders by not ejecting immediately after a mid-air collision. The regulations existed for a reason: to save pilot lives. If Nedivi's decision became celebrated, other pilots might attempt similar recoveries in situations where they should eject. The next pilot who tried might not be as skilled, might not be as lucky. They would die. So the Air Force grounded him. A 3-month suspension, not as punishment for doing something wrong, but as a message to every other pilot: follow the procedures, eject when necessary, don't be a hero. Nedivi accepted the grounding without complaint. He understood the reasoning. But privately, he maintained his position. The aircraft was flyable, the engines were good. Ejection would have wasted a perfectly recoverable F-15. He was probably right, but the Air Force couldn't say that officially. F-15D serial number 957 was transported to an Israeli Air Force maintenance depot for detailed inspection. Engineers examined every structural component, every rivet, every weld. They were looking for stress fractures, hidden damage, any indication that the violent flight had compromised the airframe beyond repair. Surprisingly, the fuselage showed minimal stress damage. The landing gear struts needed replacement from the hard landing. The brake assemblies were destroyed. The left wing showed minor stress cracks from asymmetric loading. But the core structure, the titanium longerons, the main bulkheads, the engine mounts, remained intact. The engineers made their assessment. The aircraft was repairable. A new right wing was manufactured and attached, new hydraulic lines installed, new fuel cells integrated. The aircraft received new landing gear, new brakes, new flight control systems. After 3 months of intensive work, F-15D number 957 was declared airworthy. It returned to operational service, and Zivi Nedivi, his grounding complete, returned to flying it. For nearly a decade after the incident, the Israeli Air Force kept the details classified. The official record stated only, F-15D number 957 sustained damage during training exercise, successfully recovered to base. No mention of the missing wing, no photographs released, no pilot interviews authorized. The reasoning was strategic. If Israel's enemies, Syria, Iraq, Libya, knew an F-15 could survive losing a wing and still fight, it might affect their tactical calculations. Better to keep the incident quiet. Let adversaries believe F-15s were as vulnerable as any other aircraft to battle damage. But stories like this don't stay buried forever. In the early 1990s, details began leaking through aviation publications. Retired Israeli Air Force officers gave interviews. McDonnell Douglas engineers presented the case study at aerospace conferences. By 1995, the full story had entered public domain, complete with photographs of the damaged aircraft and Nedivi's identity confirmed. The aviation world reacted with a mixture of awe and skepticism. Some engineers insisted the photos were manipulated, that no aircraft could physically do what was claimed. Others demanded to see the flight data recordings, the simulator results, the engineering analysis. McDonnell Douglas eventually published a limited technical paper confirming the basic facts. Yes, an F-15 had flown without its right wing. Yes, the pilot had landed successfully. Yes, the aircraft had been repaired and returned to service. The F-15's reputation was already formidable. This incident made it legendary. By 2025, the F-15 Eagle has accumulated the most lopsided air-to-air combat record of any fighter aircraft in history. 104 confirmed air-to-air kills with 0 losses in air combat. Let that sink in. 104 to 0. This record spans multiple air forces and multiple decades. Israeli Air Force, 58 confirmed kills. Syrian MiG-21s, MiG-23s, MiG-25s, and MiG-29s during the Lebanon War and various border incidents throughout the 1980s and 1990s. United States Air Force, 34 confirmed kills. Iraqi MiG-29s, MiG-25s, and MiG-23s during Operation Desert Storm and subsequent operations. Serbian MiG-29s during the Kosovo War. Saudi Royal Air Force, 12 confirmed kills. Iraqi Mirage F-1s and MiG-29s during the Gulf War and border incidents. The reasons for this dominance go beyond just pilot skill or tactics. The F-15's design philosophy prioritized 3 elements: overwhelming thrust, superior radar that detected enemies first, and long-range missiles that killed opponents from beyond visual range. But Nedivi's incident added a fourth element to the F-15's reputation: survivability. Other fighters might equal its thrust or match its radar, but no other fighter had demonstrated the ability to sustain catastrophic damage and remain flyable. What emerged from the declassification was a surprising revelation. Nedivi's incident wasn't unique. It was simply the most extreme example of F-15 survivability that had been documented. In 1982, during the Lebanon War, an Israeli F-15A took multiple 23mm cannon rounds from a Syrian MiG-21 during a dogfight over the Bekaa Valley. 7 rounds struck the left wing, 2 penetrated the fuselage, 1 destroyed a hydraulic pump. The pilot, experiencing severe control problems and leaking fuel, managed to disengage from combat and fly 40 miles back to Israeli airspace before landing with 1 hydraulic system and partial flight control capability. The aircraft was repaired and flew combat missions the following week. In 1983, during a training exercise at Nellis Air Force Base in Nevada, 2 U.S. Air Force F-15As collided during close formation flying. The impact crushed the leading edge slats on one aircraft's left wing and damaged the wing spar. The pilot felt immediate control difficulties but maintained flight. He flew the damaged F-15 for 15 minutes back to Nellis and executed a successful landing despite asymmetric lift from the damaged wing. Investigation revealed the wing spar had cracked 60% through its cross-section. Structural engineers calculated the wing should have separated in flight. It didn't. In 1991, during Operation Desert Storm, a Saudi Royal Air Force F-15C engaged Iraqi aircraft and took ground fire while egressing the combat zone. Anti-aircraft artillery struck the right horizontal stabilator, tearing away approximately 40% of the surface. The pilot felt the impact and experienced significant control difficulty, particularly in pitch control. He flew 150 miles back to his base in Saudi Arabia and landed successfully. Post-flight inspection showed the remaining 60% of the stabilator had carried the entire control load during the return flight. Each of these incidents reinforced the same conclusion: the F-15 was absurdly tough, and its design characteristics gave pilots survival options that shouldn't theoretically exist. Nedivi's landing influenced fighter design philosophy for the next generation of aircraft. When the United States began developing the F-22 Raptor in the 1990s, engineers incorporated graceful degradation principles into the design specifications. The concept: if the aircraft sustains damage or system failures, it should lose capability gradually rather than catastrophically. Examples in the F-22: redundant flight control systems that can operate with multiple computers failed, thrust vectoring nozzles that can provide control even if traditional control surfaces are damaged, distributed electrical systems that can route power around damaged areas. The F-35 Lightning II took this concept further with prognostic health monitoring. The aircraft constantly monitors its own systems and can predict failures before they occur, allowing pilots to make informed decisions about continuing missions or returning to base. But these modern systems are digital, electronic, computer-controlled. The F-15's survivability was analog, mechanical, almost accidental, the result of design choices made for other reasons that happened to create exceptional structural resilience. F-15D serial number 957 flew operational missions for another 20 years after the incident. It participated in combat operations, training exercises, and air defense patrols. Pilots who flew it reported nothing unusual about its handling characteristics. The repairs had been thorough and complete. In 2003, the aircraft was finally retired from frontline service after accumulating over 7,000 flight hours. Rather than being scrapped or sold, the Israeli Air Force preserved it as a training aid and museum piece. Today, it sits in an Israeli Air Force museum, restored to its post-incident configuration. 1 original wing, 1 replacement wing, with photographic displays showing the damage it sustained and explaining the physics of its impossible flight. A plaque near the aircraft reads, F-15D number 957, landed May 1, 1983, without right wing. Pilot, Captain Zivi Nedivi. Proof that the impossible is only impossible until someone does it. 8 tree elements converged on May 1, 1983 to create survival from impossible circumstances. Remove any one element and Nedivi dies. Understanding these elements reveals why his landing remains unique 4 decades later. Element 1, the aircraft design. The F-15's wide, flat fuselage generated 40% of total lift, an accidental byproduct of packaging 2 massive engines side by side. At 500+ miles per hour, this lifting body effect partially compensated for the missing wing. The enormous horizontal stabilators, nearly as large as a smaller fighter's entire wing, created downforce on the left side that counterbalanced the remaining wing's lift. The massive thrust-to-weight ratio, more than 1-to-1 with afterburner, effectively powered through aerodynamic instability, using brute force to maintain speed sufficient for fuselage lift generation. These 3 features existed independently in the design. None were intended for single-wing flight, but together, accidentally, they created just enough capability to keep the aircraft airborne if the pilot was skilled enough to exploit them. Element 2. The conditions. The collision occurred at 11,000 feet, high enough to give Nedivi time to assess and react. Lower altitude would have meant ground impact during the initial spin. The weather was clear. Unlimited visibility, no turbulence, no crosswinds. Any weather complications would have made control impossible. Ramon Air Base was only 10 miles away with an 8,000-foot runway. A longer distance would have exhausted fuel. A shorter runway would have been insufficient for the 260-knot landing. The fuel loss, while severe, wasn't instantaneous. The aircraft maintained enough fuel for approximately 2 minutes of afterburner operation, just enough time to reach the runway. Change any one of these variables, and the outcome changes. Element 3. The pilot. Zivi Nedivi had over 1,000 hours in F-15s when the incident occurred. That experience created muscle memory, control inputs so ingrained they became reflexive. When the aircraft entered its post-collision spin, Nedivi's hands moved before his brain consciously processed the situation. Afterburner, stick neutral, maintain speed. But experience alone wasn't sufficient. Nedivi possessed something rarer, the ability to make decisions under extreme stress without panic. When his wingman reported the wing was gone, Nedivi didn't freeze, didn't doubt, didn't waste seconds processing the impossibility. He accepted the information and immediately asked, "What does this change about my plan?" Answer, nothing. The aircraft flies, keep flying it. This decision-making speed, assess, decide, act, all within seconds, separates exceptional pilots from merely good ones. Psychologists studying Nedivi's incident identified a cognitive pattern called positive problem-solving bias. When facing an apparently unsolvable problem, most people focus on why it can't be solved. A small percentage focus instead on what might make it solvable. Nedivi demonstrated this bias perfectly. When told his wing was gone, normal response, "The aircraft can't fly without a wing. I must eject." Nedivi's response, "The aircraft is flying without a wing, therefore it can fly. What do I need to do to keep it flying?" This subtle cognitive shift, from focusing on impossibility to focusing on current reality, made the difference between ejection and landing. Modern militaries now screen fighter pilot candidates for this trait. Simulator scenarios deliberately present impossible situations and measure whether candidates focus on why something can't work or how to make it work despite apparent impossibility. Nedivi's landing resonates beyond aviation because it demonstrates 3 universal principles. 1. Design margins matter. The F-15's engineers never intended single-wing flight capability, but they overbuilt the aircraft structurally, provided massive thrust reserves, and created redundant control systems. These excessive margins meant the aircraft had hidden capabilities beyond its design specifications. Lesson: build in margins, over-engineer, create redundancy. The extra capability will never be wasted. It provides options when everything goes wrong. 2. Training beats instinct. Nedivi's reflexive response to the spin, afterburner, stick neutral, maintain speed, came from hundreds of hours of practice. Under stress, training overrides instinct. Instinct says, escape immediately. Training says, assess, then act. Lesson: repetitive training under stress creates automatic responses that work when conscious thought is too slow. 3. Accept reality, then solve it. Nedivi didn't waste time arguing with his wingman about whether the wing was really gone. He accepted the information and immediately moved to problem solving. No denial, no disbelief, instant adaptation. Lesson: when reality contradicts expectations, believe reality immediately. Every second spent questioning wastes time better spent adapting. In 2015, more than 30 years after the incident, retired Zivi Nedivi gave an extended interview to an aviation magazine. The interviewer asked the question everyone wanted answered. Looking back, knowing how close you came to disaster, would you make the same decision again? Nedivi's response was immediate. Absolutely, without question. He explained his reasoning. When you're in that cockpit, when you're making decisions in seconds with incomplete information, you trust your training and you trust your aircraft. The F-15 was telling me it could fly. The engines were good. The controls responded. I had no reason to think we couldn't make it to Ramon. The interviewer pushed. But you couldn't see the wing was gone. You were flying blind. No, Nedivi corrected. I was flying on information. My wingman told me the wing was gone. Okay, but the aircraft was still flying. That was more information. The question wasn't, should I eject? The question was, can this aircraft make it to the runway? And every second we stayed in the air, the answer was yes. 42 years after the incident, one question remains. Was Nedivi right to land instead of ejecting? The Israeli Air Force says no, officially. Procedures exist for a reason. Following them saves lives. Nedivi violated procedures. 3-month grounding was appropriate. Aviation safety experts say no. Statistics show that attempting recovery in extreme situations has lower survival rates than immediate ejection. The math favors ejection. Engineers say maybe. The F-15's unique characteristics created a survivable situation, but only Nedivi could know in that moment whether the aircraft was truly controllable. His decision was defensible given the information available. Fighter pilots universally say yes, the aircraft was flying, the engines were good. You don't abandon a flyable aircraft, ever. And Nedivi himself says yes, still, 4 decades later, without hesitation. The F-15 told me it could make it. I listened to my aircraft. We made it together. Perhaps the truest answer is this. Nedivi was right because he survived. Had he crashed, he would have been wrong. In aviation, as in life, outcomes often define correctness more than logic or procedures. The one-winged F-15 landed safely, not because it was designed to, not because procedures allowed it, not because logic suggested it was possible. It landed because a pilot believed his aircraft, trusted his training, and refused to accept that impossible meant unachievable. And sometimes, belief and skill together create outcomes that shouldn't exist.